G'day guys, we're going to do a back or indirect titration question today. So let's see what we're up against. We've got a 1.0101 gram sample of FeOH to the lowercase n was mixed or mixed with 20 mils of 2 mol per litre hydrochloric acid and enough water to make 200 mils of solution A. We'll call that solution A there. A 25 ml aliquot of solution A was taken and titrated with 14.56 mils of 0.1 mol per litre potassium hydroxide according to this equation here. What is the value of N? Okay, so the way we're going to solve this, and the way we would solve any indirect or back titration problem, is we're going to work out the amount of potassium hydroxide that was titrated with the hydrochloric acid, and from that we'll be able to find the hydrochloric acid remaining after it is reacted with FeOH to the lowercase n. Once we know what the hydrochloric acid is that's remaining, we can then take it away from the initial amount of hydrochloric acid and find the amount that's reacted. Once we've done that, we'll be able to find the amount of this that caused the reaction. So without further ado, let's get on to this problem. So what we're going to do first is we're going to calculate the number of moles of potassium hydroxide required in this reaction. So number of moles of potassium hydroxide, and we're going to use the formula. This is going to be equal to the number of moles, is going to be equal to the concentration times the volume, which is equal to 0.1 times 0.01456, and that's going to give us a value of 0.001456. Cool. Now, from our equation here, we can see that the number of moles of hydrochloric acid is going to be in the same ratio or the same quantity as the number of moles of potassium hydroxide required. So, we can write that down. Cool. So that's the amount of hydrochloric acid that's going to be remaining after it reacts with the iron hydroxide up here. So what we're going to do now is then we're going to convert this. This is how much hydrochloric acid is in 25 mils. So what we're going to do now is we're going to work at how much we have in 200 mils. Now, so what I do is I like just to work out the scale factor that this is increasing by. So I'll just go 200 divided by 25, which is going to be 8. And then I'm going to multiply that by the moles of hydrochloric acid in the 25. And that gives me 0.011648. So that's going to be how much is remaining in the 200 mils after it reacts with the iron hydroxide. So what we're going to do is we're going to work at how much is there before it reacts with the iron hydroxide. So we're going to work out, we're going to go the number of moles of hydrochloric acid is equal to the concentration times the volume, which is equal to 2 times 0.02, which is equal to, doesn't take a rocket scientist, 0.04 moles. Cool. So what we can then do is, once we've got that, we can work out the number of moles of hydrochloric acid that's consumed through its reaction with the iron hydroxide. And that's just going to be the number of moles to start with. Subtract the number of moles that we end up with. And that's going to be equal to 0.028352. Cool. Great. Now, there are two different states this iron hydroxide can take. We could either have iron 2 or iron 3. Now, in these two situations, if I have iron 2, this equation here is going to obviously look like this. If I have iron 3, okay, so what we're going to do is we're going to work out, using these molar ratios, how many moles we'd expect to have of each of these. So what we would do is we'd go the number of moles of FeOH2. Oh my god. Would be equal to the number of moles of hydrochloric acid divided by 2, which is equal to 0.014176. And for the second one, the second option, Fe that's going to be equal to the number of moles of hydrochloric acid divided by 3, which is equal to 0.009451. Cool, now let's put some units on these. So this is mole. Great. So now what we're going to do is we're going to work out what the molar mass of iron hydroxide is, and we're just going to multiply it by each of the molar quantities. So we'll start up here. So we can say the mass, if we had FeOH2, would be equal to the mass of iron hydroxide, which is going to be, iron is 55.85, plus 16 times 2 plus 1.008 times 2. And we're going to multiply that by the molar amount, which is 0.014176, and that gives us a mass of 1.274. And what we can then do as well is we're going to work out do exactly the same for the FeOH3. So that's going to be 55.85 plus 16 times 3 plus 1.008 times 3, and all of that has to be times by 0.009451, and that gives us a weight of 1.0101 grams. Alright, so as this matches this, it's quite easy to see that the compound that we have in the sample must be, so we can write therefore, the compound must be FeOH3. So, and from that, the question actually asks, so we can say that N equals 3. And you can see there that we've finished our back titration. Now, let's just go through a few steps. That what we did is, to start with, a back titration involves mixing a solution that's in excess with the solution that we're trying to analyze. Now, what we do is then we then titrate against the remaining solution, not the solution that we're trying to analyze. So we titrate against the remaining solution of the solution that was in excess. We do that because once we know what is remaining in the excess solution, we know what we put in, we can then calculate the amount of that solution that was consumed. And from that, we can then, knowing how the solution reacts with the compound that's trying to be analyzed, we can then figure out what the amount or moles of compound is in the actual original solution that we're trying to work out. So this problem here was a little bit tricky. Trying to find the value of N meant we had to come up with all the different combinations of iron hydroxide. But apart from that, it's not too tricky. It's just we have to work through all the steps. So again, I hope my video helped. If it did, give it a like, subscribe to my channel, and I'll see you again next time.